Hi everyone. In this session, we have to discuss about some water treatment methods. So first one is zeolite or permutate process. Next, ion exchange or demineralization process. These two processes are important to remove hardness from hard water. After this treatment, the resulting water is used as a feed water in boilers. So first one is zeolite or a permutate process. Naturally occurring hydrated sodium aluminosilicates are called as zeolites, and the general formula for zeolite is given here. If that zeolite is synthesized in laboratory, then we can call it as a permutate, and that general formula for permutate is given here. So naturally occurring zeolites are obtained from green sand and they are non-porous, and example is natrolite. If that zeolite is synthesized in laboratory, then we can call it as a permutate. Already we know that. Now this can be prepared by heating china clay with feldspar and soda ash. These permutate are having ion exchange property when compared with the natural zeolites, because these synthetic zeolites are porous in nature and they are jelly in structure. This is the process, permutate process. In this process, we are using sodium aluminosilicates as a zeolite bed here, and that hard water is allowed to percolate through the bed, and that sodium ions presented in that sodium aluminosilicates are exchanged with the calcium and the magnesium ions of the hard water. Now that water which is coming out of this zeolite bed is having only anions. It does not have any cations like calcium and magnesium. So it is having only sodium cations and anions as such. So now that water is coming out through this outlet is called as a soft water, because it does not have any calcium and magnesium ions. So that ion exchange method is given here. So that permutate is represented as Na2Ze, and these sodium ions are replaced with calcium ions of that hard water, and all the magnesium ions also replaced through this bed, and now that zeolite is having only calcium and magnesium ions. So all the sodium ions present in that zeolite is removed as a sodium bicarbonate, okay, or sodium chloride. Now that bed is saturated with a certain volume of that hard water. After that, that regeneration of bed is very important. So now that water which is coming out through the outlet is having only sodium ions and cations as such. Anions as such, because anions cannot be removed by this method. So regeneration process. So now zeolite is completely converted into calcium and magnesium zeolites. So at certain point that water treatment process will be stopped, because that zeolite bed is saturated with a certain amount of calcium and magnesium ions. Now that bed is washed with sodium chloride, that means 10% sodium chloride, which is called as a brine. Now all the calcium and magnesium ions are removed and sodium ions are regenerated on the surface of the zeolite bed. So now all the calcium and magnesium zeolites are converted into sodium zeolites, and these ions are removed as chlorides. Now advantage and disadvantage. In this process, sludge is not formed during the process, and hardness is zero, because that obtained water is not having any calcium and magnesium. So the operation is very easy, and this method is very cheap and cost effective, and sometimes it is very easy to do that water treatment method, and it occupies very small space. Space is not an issue here. And then disadvantage. So if that water contains more turbid and acidic, then we cannot use this water treatment method, because the turbid will block the pores of the zeolite, and if the water is acidic in nature, means it will destroy the zeolite bed. Next one is only cations only we are replacing by using this method. Anions will not be replaced. So if that soft water contains anions, then that will generate some gases. Because if that water is having bicarbonates, then that liberation of CO2 is possible. So it will increase the pressure inside the boilers. That will be a problem for boilers. Next one, due to formation of sodium hydroxide, the water becomes alkaline in nature, and that ion magnesium presented in that hard water cannot be treated. So it will be interference while we doing that regeneration process. Next one is ion exchanger or demineralization process. So ion exchange or demineralization process removes almost all ions. In this process, we can remove both anions as well as cations presented in that hard water. We are using polymeric resins in this method as exchange resins, ion exchangers. So that polymers resins are made up of crash linked long chain, and those are insoluble insoluble in water, and they are also having microprocess structure. So the functional groups which is attached with that resins are responsible for ion exchange property. So first one is cationic exchange. So that resins contains carboxylic acid group and sulfonic acid group are responsible for cationic exchange. That means the H plus ions presented in that carboxylic acid group and sulfonic acid group are the responsible for replacement of calcium and magnesium ions presented in that hot water. So these cationic exchanger are represented as RH2. Some examples are sulfonated polystyrene and RSO3H and RCOOH. Anionic exchanger. So in these resins, in this anionic exchanger, the resins containing basic functional groups like amine groups and OH groups. These amine groups and OH groups are responsible for anionic exchange. These ions are exchanged with the chloride, sulfates and bicarbonates of bicarbonates presented in that hot water. This can be represented as ROH2. These are the examples. Quaternary ammonium salts are mostly common anionic exchange resin that is used in this process. So procedure. First, hot water is passed through the cationic exchange column. So now that H plus ion presented in that exchanger is replaced with calcium and magnesium ions presented in that hot water. That means these H plus ions are exchanged with calcium and magnesium ions present in that hot water. Now that water is coming out through this outlet is acidic in nature, and it is having only anions and H plus ions. So it is acidic in nature. Now that water is allowed to pass through the anionic exchange resin. Now that OH groups, OH minus presented in that anionic exchange resin replaces that anions presented in that hot water. That means that chloride, sulfates, bicarbonates are exchanged with OH minus, and then water which is coming out through this column is having slightly neutral, because that OH minus which is existing in this column reacts with the H plus ion which is existed in this column. Now H plus and OH minus combine together to form neutral soft water. So now that water which is coming through out of these exchangers free from both cations as well as anions, now that ion free water is called as deionized water or demineralized water. So regeneration of the resins. After completion of this process, that anionic exchange resin and cationic resin, both resins are saturated with calcium, magnesium as well as bicarbonates, chlorides and sulfates. So that cationic exchange resin is regenerated by passing through the dilute sulfuric acid or H2SO4. That dilute HCl or H2SO4 is passed through the that cationic exchange resin. Now that calcium and magnesium ions are replaced there, and H plus ions are generated again. So now that cationic exchange resin is again reformed. Similarly, in anion exchange resin, sodium hydroxide is used to wash that bed. Now that OH minus ions from that sodium hydroxide removes that chloride, sulfates, bicarbonate, and anionic exchange resin is now regenerated. So now that washing which is coming out from both column is having sodium sulfate and NaCl, both of these are removed and passed into the sink. And what are the advantages? In this method, highly acidic or highly alkaline water can be purified because it produces water of low hardness. And disadvantage: this equipment is high cost and we cannot be used with a simple cost. And chemicals which are used for regeneration is more expensive, and turbid water reduces the efficiency of this process.